Okay, we're going to start our video on derivatives with inverse trig functions. So these are 6 more formulas that you're going to have to memorize, or maybe not so much memorize all of them, just know how they work, because you really need to memorize just 3 of them, and you'll see why here in a second. So as we go through here, look at our inverse trig functions. If you notice that a lot of them are super similar, so inverse sine and inverse cosine are almost the same thing. If you notice, they're cos of each other, they're related, and the only difference is the c is the negative. Cosecant and secant, just about the same thing, but the c is negative. And then tangent, cotangent, almost the same thing, but the c is the negative one. So these kind of come out of left field. So right down here is a reason why this all works. And you can kind of follow it through here, and which is why some of these formulas are the way they are, taking with inverse trig functions. So inverse trig function is y equals sine to the negative 1 of x, and then you would just solve for x, which is right here, and then you would differentiate it using implicit, and then you would resolve, and you would replace this with our values on our actual triangle. So yeah, the derivative of inverse sine is really 1 over cosine y. But we shouldn't have y's in our answer. So that's why we will come back here and replace it. And this y right here is actually going to be our angle. Okay. So you don't need to know how that works, but that really can help you out figure out what the heck we are doing here. Okay. So let's go ahead and do some problems with this. Again, this is going to be a lot of chain rule for what we're doing here. Okay. So the first example is derivative of arc sine of 2x. So in these examples right here, these are just the basics with just an x. So now I have a 2x inside, and this is going to involve a chain rule. So I'm going to have the 2x take the derivative of, and then the arc sine. So the derivative of 2x is going to be 2 times the derivative of the arc sine is going to be my 1 over square root of 1 minus x. But this x is really, the inside stays the same, is really going to be 2x all squared. Okay, and then simplifying this, making this look a little bit nicer, is going to be 2 over root 1 minus 4x squared. And there you go. So they're rarely going to just ask you just the parent function of inverse sine with the derivative of that. They're going to involve some type of chain rule. So that's why I take the derivative. You can do, I think I did this backwards how you did it in the other videos. You do the derivative of the outside first and then times the inside. Doesn't really matter. So let's go ahead and look at the second example here. This is actually a chain in a chain, because you got arc secant of a function, and the function is e to the 2x, which is another function. So you're going to have a double here. So take the derivative of the inside. So taking the derivative of e to the 2x is actually another chain. So inside that chain is going to be the 2x. So the derivative of 2x is 2 times the derivative of e to the 2x is e to the 2x, because you got to leave that the same. All right. And then now you take the derivative of the arc secant. And again, you probably want to be looking right at your formulas as you're doing this, because you're not familiar with it yet. So it's going to be times 1 over absolute value of the function. So it's not x, but it's e to the 2x. So the absolute value of that function times the square root of x squared. So not x squared. It's going to be e to the 2x squared minus 1. If you notice, I keep peeking at my formulas because I'm just not there yet with memorizing them, but you will be. From here, we just got to clean some things up. Now, this e to the 2x absolute value, if you know what e looks like, and even e to the 2x doesn't really matter, it's just going to make it go, jump up faster. It's always positive. So the absolute value there is not needed. So because of that, I can drop the absolute value, and I'm going to get 2 times e to the 2x times 1 over e to the 2x, and let's clean this up in here. Square root of e to the, that distributes in 4x minus 1, and now we can cancel out those e to the 2x's. Again, that only works because the absolute value is always positive for e to the 2x. And that's going to give me a final answer of 2 over square root of e to the 4x minus 1. Okay. Moving on. All right. Not a bad one either, except we are going to get a little bit of product rule on this one, because this is a function times a function. So don't forget, for product rule, it's going to be, we have d over dx of f times g. It's going to be first is first plus second is second with those derivatives. So here we go. The derivative of x is going to be 1. So it's 1 times, leave the second, arctan of root x plus x times the derivative of arctan. So we take the derivative of the inside here, which is going to be, well, that's really x to the 1/2. So that would be x to the negative 1/2. And then times 1/2. So that's the derivative of the square root of x times, it's going to do the arctan. So the arctan is going to be 1 over, it's usually 1 plus x squared. But our inside function is root x, so it's going to be root x squared. And now all I've left to do is just a lot of cleaning up. We get arctan root x plus, this is going to be x over 2 x to the 1/2 times 1 over 1 plus x. And we can clean that up just a little bit here. This is really x to the 1, so they have the same base. You can subtract the exponents. So on this side, you're going to go ahead and get a root x on top, all over 2, 1 plus x. And I didn't touch this front at all. So this is still going to be arctan root x. Okay, this one was a little more intensive, so if you needed to pause, go back, see something, it's a good one to go to redo. Last one here, this one won't take as long, is the arctan of ln of x. Sorry, ln of theta. Make sure whenever you're doing these problems, you use the same variable that they give you. So the derivative of this is going to be the derivative of the inside. The derivative of ln of theta is 1 over theta. Times, you're going to get 1 over 1 plus inside squared. So ln of theta all squared. All right? And actually, there's really nothing we can do here. Some people think that you can move that 2 in front. Now, it's not ln of theta, the theta being squared. It's ln of theta, and it's all squared. There is no rule to pull that out in front. If the theta itself was squared, then yeah, you can pull out in front. But there's nothing we can do here. So I'm just going to just rewrite as a bit of a cleanup. Theta times 1 plus ln theta, and this is all squared. And that's really it. Okay. Quick little side note. They can write this as ln squared theta on the inside, kind of like what they do for sine, and cosine, and all the other trig functions. They can write it that way. So just so you can see the notation. And that's it. And that is all of your inverse trig functions. Not a long video because you really need to be practicing this on your own to get the hang of it.